Good afternoon, everyone.
Good afternoon, ma'am.
In the previous class, we did Gauss elimination method, and today we are going to write a program in C to solve the following system of equations by Gauss-Siedel method. The system is 20x plus y minus 2z equals 17, 3x plus 20y minus z equal minus 18, 2x minus 3y plus 20z equal 25. The given system of equations can be written in the matrix form. A11x1 plus A12x2 plus A13x3 equal B1. A21x1 plus A22x2 plus A23x3 equal B2. A31x1 plus A32x2 plus A33x3 equal B3. If we write the system in this way, coefficient matrix, unknown matrix, and right hand side matrix. You have to note that you have to check that whether the given system is diagonally dominant or not. If not, you have to make it diagonally dominant. What is the diagonally dominant property? For this matrix A, the coefficient matrix A, the diagonally dominant property is sum mod AII greater equals to sum over I not equals to j mod Aij for all I. The sum of absolute value of the coefficient terms on the diagonal. So on the diagonal, the coefficient terms are A11, A22 and A33, which is greater equals to the sum of absolute values of the rest of the coefficient terms in the matrix. So the rest of the terms are A12, A13, A23, A21, A31, A32. Let us check the diagonally dominant property for this given system of linear equations. So here 10 plus 10 plus 10, all the diagonal terms, that is 30, summation of all the diagonal terms. And then rest of the coefficient terms are 2 plus 1 plus 1, absolute value, so you have to take the magnitude only, leaving the sign, plus 2 plus here 1 plus 3. So how much it is? 3, 6, 4, 10. So 30 is always greater than 10. Therefore, the given system of equation is strictly diagonally dominant. Therefore, Gauss-Siedel method is well suited for this given system of equation. Here we can construct the augmented matrix taking A and B together. Look here, this B is written subsequently the elements of the matrix. So here you see A11, A12, A13, the next term will come as A14. So B1 is substituted by A14. Similarly, A21, A22, A23, A24, this is for B2, A24 for B2, A31, A32, A33, A34, A34 is for B3. This is only for to write the program smoothly. Let us take the equations as 1, 2, 3. Then from equation 1, x1 will be A14 minus A12 x2 minus A13 x3 divided by A11. Here another point you have to note that you have to take the initial approximations as zeros. That means x1 as 0, x2 as 0, x3 as 0. These three initial approximation 0. So if we put x2 and x3 as 0 and 0, then we will have A14 by A11. Now see how to generate the Gauss-Seidel statements for the C programming. So we have got x1 as A14 by A11. We can write as xi, where I takes the values 1, 2, 3. S by AII. Okay, you see here 1, 1, so I, and 1, 4. Here 1, 4. So this S can be written as, you look, AI n plus 1. How it is, you look that I. Okay, they are same. For I equals to 1. For I equals to 1, you will get x1. S by A11. For I equals to 1, you will get x1 S by A11. What is S here? S equals to A. You have taken I as 1, so 1, and N. N is what? N is the order of the matrix. You know the system you have taken, the order is 3, so 3 plus 1 is 4. I hope all of you have understood. Next, from equation 2, okay, so from equation 2, yes, from equation 2, we can find x2. So x2 will be A24 minus A21x1 minus A23x3 divided by A22. Now you have noticed that the initial approximations we have taken x1, x2, x3 as 0, 0, 0. But here this x1 you cannot take as 0. Why? Because you have already found x1. So this new x1 you have to put here, and this x3 is initial approximation. This x3 will be the initial approximation of what is 0. So if we put 0, then we are getting A24 minus A21 x1 divided by A22. Now this thing we have to write as general statement for the programming. So how to write that? Look what we have taken. We have taken xi equal s by aii. So similar thing we have to take xi equals to s by aii. In this case, this s will be changed. So this s will be according to this numerator. So here you look here that this A24 minus A21 multiplied by x1. Okay, so here we have not written any A24. What we have written? We have written s minus aij here, this A21 aij here, and multiplied by x1. So here xj. This j for what I value is, for this case what is I? Okay, let me write first this thing. x2 equals to this, and we got xi as s by aii, where s equals to this much. So in this case I equals to 2. Then we have x2, right? So s by a 2. Okay, so it matched already. Now we have to check this s. So what is s? S equals to s minus a. We don't know this. We don't know this s. Okay, so here I is 2, that we know. So I is 2, and j we have to take here for 1. Let me first write j star multiplied by xj. So when j equals to 1, look here, j is 1. So when j equals to 1, then s is how much? This s. How much this s? This s you will find from the previous one. So this s minus a 2 1 multiplied by x1. Look here, this part. So this s, how much will you get from the previous one? The previous one, you will get this s, right? This s, you see here, this s is how much in the previous slide. You see, this is the initial s. Okay, starting s. Okay, so this s is the first iteration s. We are finding x2 for the first iteration. So at the first iteration, while we are finding x1, s is a, it was I, and n plus 1. Okay, so in this case, what is I? I is 2. So I is 2, that is a2, and n plus 1, as you know, n is the order of the matrix. So 3 plus 1, that is 4. Now you look, how much are you getting? So you are getting actually a24 4 minus a21 multiplied by x1. Okay. Okay. You look here that the numerator is a24 minus a21 x1. You look here, a24 minus a21 multiplied by x1. So it matched, and below it is a22. Hope all of you have understood. Have you understood? Next. Well, it does not go to the next slide. What is the problem? Okay, from equation 3, we will get x3 as a34 minus a31 x1 and then minus a32 x2 and divided by a33. Now the same statement xi is s by aii, where s equals to s minus aij multiplied by xj. What we have taken in the previous, I don't know why it is not moving. It is not moving at all, the slide. Sometimes it moves, sometimes it does not move. Okay, we have got xi as s by a I. Okay, where s is s minus a I j multiplied by xj. So it is similar for the third equation also. Now let us check for I equals to 3. So x3 is s by a 3. Okay, and s is s minus a. So here ij means 3 and j you do not know, so keep it like this, multiplied by xj. Now you look that if you go to the previous slide, I got so many slides. Yes, here. So you look that for j equals to 1, you are getting this expression. Here you look that this term is extra. The previously what you have got 2, 4, then 2, 1, x1, and here you got a3 to x2. So in this case j is 2. For j is 2, s equals to s minus a 3, 2 and x2. Okay, check here, a32 minus x2, and this much is actually s that we have to find for j equals to 1. So this s is what? This s you will get from the previous one. So the previous one, it was s equals to s minus a I j x j. So previously I is always 3 for this case, right? So previously s you have got s minus a 3 and then j is 1 multiplied by x1. So what you have got? You have got this value, then you have got this value, and this s you require. You see that you have got this. So you need this part. So this part you will get from the beginning. So where it was? Here. Here you see S equals to AI n plus 1. So let us put S equals to AI n plus 1. So for this case I is 3. So A 3 and as you know this is 4. Now you put all of this A 3 4 minus A 3 1 A 3 1 multiplied by x1 minus this part A 3 2 multiplied by x2. So we have generated all the statements for the Gauss-Siedel method. Is that clear to you? Is that clear?
Yes, ma'am.
Now you see that the programming code already I have written to save the time. So here, as you know that the input, so the inputs are to be read. What are the inputs? The inputs are the order of the matrix, then the elements of the augmented matrix and the initial approximation. Now the statements which we have generated, we have incorporated those, all of them. Okay, so the statements what we have generated, we have incorporated all of those. Now we have the system with us. This is the system. Here the values for the elements of the matrix: 21 minus 2, 17, 3, 20, minus 1, minus 18, 2, minus 3, 20, 25. So let us execute and run. Order of the matrix 3, A11, 20, A12, 1, A13, minus 2, A14, 17, A21, 3, A22, 20, A23, minus 1, A24, minus 18, A31, 2, A32, minus 3, A33, 20, A34, 25. Now let us enter the initial approximations. What I said you that 0, 0, 0. Okay, so we got the output. X1 is 1, X2 is minus 1, X3 is 1. So hope all of you have understood. I have given one problem in the GC. Take that problem and you do it yourself.